Here we have a question where we're trying to find the cosine of the tangent inverse of 15/14. So let me write that a little cleaner for us down here. We're trying to find the cosine of the tangent inverse of 15/14. How do we do it? So notice what we're dealing with here. We're dealing with a regular trig function and an inverse, a composition. We're composing, we're putting those two together. And they're different trig functions. It's cosine and tangent inverse. Rather than, we did a bunch of them where they were the same, like cosine inverse, or tangent, well, I guess we didn't do tangent. We did like sine inverse of sine, and the same trig function. But this one is a different one, a mix, cosine and tan inverse. How do we do that? Well, I provided some notes for you. If you go back to the notes, here it is. It's this last section of the notes for 8.3. It says composition of different inverse and regular trig, like cosine and tan inverse. That's the exact example we're doing. How do we handle this? Well, step one, we start on the inside, and we say, look, the inside, that's equal to A, where A is some angle. That's what it means, that you put an answer into tan inverse, and it's equal to an angle. We can say, and then we can say it the other way. We can turn it around, and then we can put it on a triangle. And then we do the Pythag, and then we go to the outside. Let me go back and show you. I'll come back to that, but let me begin some of those steps. So, step number one, we start with the inside. So right here. So grab that. That says tan inverse of 15/14. Now that's got to be equal to what? Well, remember, for a normal tan function, you plug in an angle, right? For normal sine, cosine, or tangent, you plug in an angle, you get out an answer. For inverse tangent, you plug in an answer, you get out an angle. It reverses that, right? That's what inverse functions of all kinds, not just trig functions, but all inverse functions do. They reverse the inputs and the outputs. So anyway, so this must be an answer because it's inside of an inverse trig. So it must equal an angle. Let's call it A. You can call it Joe. I'm just making up a name for an angle, A. So it must equal some angle. Let's call it A. So then you can, let's make it a verb. Invert. Then we can invert things. If the tangent of 15/4 is A, then, swap this. If the tangent inverse, then regular tangent of the angle must be 15/14. So right now I put the angle inside here and the answer there. That must mean that. That's the definition of an inverse function, right? If the inverse tangent of 15/14 is A, then swapping it up, the regular tangent, no longer inverse, of that same angle must be 15/14, right? You can just swap the answer and the angle when you go to the regular tangent from the inverse. You're just inverting it. That's what it means to be an inverse trig function. Okay, great. So what? Well, now we can go to a triangle and draw that reality. Let's do it. So maybe I'll come down here, we got a little more room. Going to make a right triangle. Put a little right angle here. And I'm going to stick angle A in there. Right here. You can put it up there. It doesn't really matter. And now let's remember SOHCAHTOA. Remember SOHCAHTOA? We're doing tangent right now. So tangent, this means tangent equals opposite over adjacent. That's what TOA means, opposite over adjacent. So remember how the sides work here. This is the opposite side here. Because it's opposites across. This is the hypotenuse. Because that's the side across from the right angle. It's the biggest side in the triangle. And this, therefore, is the adjacent side because it's next to A. See how it's touching A there? It's next to A, like your neighbor lives adjacent to you. So, okay. So, tangent then. So what does this say? Let's bring this down here. Where we can see it right there. So this tangent is opposite over adjacent. So this must be opposite. This must be adjacent. So the opposite is 15. The adjacent is 14. That's what it says, right? Tangent is opposite over adjacent. 15 over 14. 15 must be the opposite, 14 adjacent. And now, so that's all step one. Step two, we're going to find, this is C, find the missing side using a squared plus b squared is c squared. That's true for any right triangle. The Pythagorean theorem is true for any right triangle. So, it doesn't matter, A and B, the order does not matter. You can swap them, it doesn't matter, they're just added. C though, C is the hypotenuse, and so that side must be alone. It's the longest side in the right triangle. So the other two squared must add up to equal it. It's the biggest one. So now let's solve for C. 14 squared, you're going to use my calculator. I think it's something like 196. Yeah. So 196 plus 15 squared is, I believe, 225. Yeah. Equals C squared. Add those up. I'm getting 421 is C squared, and then we root it. So C is the square root of 421. And I'm just going to leave that. You can do it on your calculator. It's just some ugly decimal. They want me to leave an exact answer. You won't have a calculator during this part of the exam. Now, I hope that doesn't panic you. You can certainly multiply 14 times 14 by hand, right? 16, 4, add 1 is 5. Add a 0, 4, 1, add it up, 196. You can do the same thing for 15 times 15, and then you can certainly add these numbers, and we'll just leave the root. No calculator needed, right? So, square root of 421. Now, we're one more step, and we'll have it. Step 3 is finish the outside. I'll show you back on the notes. So back here on the notes, step 2, is do the Pythag, find the other side. Step 3, find the trig function on the outside. Go back to the outside and finish her up. Okay, let's do it. So, back to the outside. What was the original question? Let's grab it and bring it down. So here was the original question. We can bring it on down. Bring it on down here. Cosine of tangent inverse of 15/14. Like that, right? And so now what is tangent inverse of 15/14? Well, it says right here, tangent inverse of 15/14 equals A. So this whole inside, tangent inverse 15/14, that's A. It says so right here, right? So this problem becomes the cosine of A, doesn't it? Now we can finish the cosine on the outside. How so? Well, let's look at this triangle. We can find the cosine of A. Remember SOHCAHTOA. Cosine is adjacent over hypotenuse from the SOHCAHTOA definition of sine, cosine, and tangent. So this is going to be adjacent over hypotenuse. That's what cosine always is. So in this triangle, cosine of A is adjacent, 14, over hypotenuse, and that's C. I forgot to put it up here. C is square root of 421, right? Over the square root of 421. And they tell us in this problem that we can just type in the answer like this. But in most, that's nice of them to do that, but in most classes, so this is the answer. They'll take it like this, but in most classes you'll take, if you go on to calculus and stuff, they're going to want you to get rid of the root. So that's easy to do. You just multiply top, we don't want roots on the bottom. So you multiply top and bottom by root 421. So we'll get 14 root 421. On the bottom, what's root 421 times root 421? It's a plane 421, right? Two of the same roots, just gets rid of it. And so that would be our final answer, where we no longer have a root in the bottom. The program will actually take this answer right here also. It'll take either one. Both, it'll be good. Look for it this way on the exam, though. On the exam, it could be either way. Yeah, you should know either way. They're both right. Whether you leave the root in the bottom or you get rid of the root from the bottom, those are two ways to say the same answer.